All right, what's up, ladies and gentlemen, to another live stream for Open Live Q&A for semester exams. So I have some more questions that I was not able to get to. So therefore, I am going to add in another weekly stream, and then I'm probably going to have to do this again Wednesday. I don't know what time I'm going to be doing it, though. So therefore, you're just going to have to stay true to the channel or have the bell notifications. Or also, you can always go back and check these as a replay. I will put them all in a nice little playlist. So therefore, if you do post a question, that you can go back and watch the replay if obviously you're in school or it's in the middle of the night for where you live, like whatever could be the case. I did want to let you guys know though, if you do have questions, I still will, I'm still am accepting questions. So therefore you can just go to brianmclogan.com/Q&A and submit your questions over there. And yeah, so that's basically what I'm doing. I'm just working through the backlog of questions that I have. So I have quite a bit of questions. I'm going to try to do 10 today, and that's just a cutting them down because I have more than 10 here so far. So I'm trying to do the best that I can to get as many questions answered. And I do apologize if you have some time urgency, but I'm just going to kind of work through the questions as I receive them. Also, just want to let you guys know, if you are in pre-calculus and you are interested in taking or interested in my pre-calculus exam, like review, exam courses, videos of me going through all of them, free response, multiple choice. I think there's like, I don't know, over like 500 questions that I basically have answers and provided solutions to. So if that is something that you are interested in, then you can go and check a link. It is premium though. It's not a free course. Like obviously I do this for free. These open and the Q&A, but for the pre-calculus course, that is a paid course. I do want to make sure that you are doing your best. So I put in a lot of time and effort to make sure that you are going to knock your pre-calculus exam. And I apologize, I don't have it for any other course. I just have it for pre-calculus at the moment. The other thing is, what else was I going to say that with, my Spreadshop. I don't know what's working on with that. And also on the pre-calculus exam course, there also includes a open Q&A, just like I'm doing here. So therefore I will be doing that as well. So if that is something you are interested in, to kind of get like your questions answered, and stuff like that, you guys can definitely go ahead and, sign up for them in there. And pre-calculus is anywhere. I have students from 10th grade all the way to the 12th grade, students in college. So it's really not a grade portion of it, but typically it's going to be something you're going to take after an algebra 2 or like a college algebra prior to a pre-calculus. Well, awesome. So happy to hear. All right. See you later, Caden. All right. So let's go ahead and go through some of these questions that I have. All right. So the first one is cosecant plus cotangent of x. I need to find this in the radians. Okay. So first thing that I always like to do is, I don't really see an easy way to solve this. So the first thing I'm going to do is I'm just going to rewrite this in terms of sines and cosines. That's a sine of x. I'm sorry, that would be tangent. So therefore this is going to be a cosine of x over a sine of x. Okay. So therefore this would be a 1 plus a cosine of x all over a sine of x, right? Because they have common like terms. Equals a 1. All right. And so I can get rid of this denominator, right? So I can multiply by a sine of x on both sides. And that's going to leave me with a 1 plus a cosine of x equals a sine of x. Okay. So again, I can't really do anything. Like even if I get this sine of x over to the other side, like set equal to 0, try to look into factoring, I'm kind of striking out. And the one thing I notice is sometimes when I do strike out on dealing with sines and cosines, I want to kind of create my identities, right? And if you remember the Pythagorean identity, sine squared plus cosine squared equals 1. Well, the only way I can use that identity is if these are squared. So one thing I can do, which you've got to be very careful on, is squaring both sides. Now, the reason why I say be careful with squaring both sides, because that can produce what we call extraneous solutions. Solutions that are true for the final answer, are true for this final equation, but are not true for the original equation. So whenever we like raise something to a power, or, squaring, raising to the power to be able to solve, we got to make sure we go back and check our solutions. So 1 plus cosine of x squared equals sine of x squared. All right, so let's go ahead and factor this out. So this is 1 plus this expanded would be a 2 cosine of x plus a cosine squared of x. And this is going to equal a sine squared of x. Okay, and Now I don't want sine squared and cosine squared. So one thing I can do is I can rewrite the sine squared. So again, let's write out that. So for those of you that don't remember, sine squared of x plus cosine squared of x is equal to 1, right? Now, again, we want to solve. So typically when you have sines and cosines, something you want to do is maybe like rewrite them all within the same term or all within the same sign. So since I already have two cosines, let's see if I can convert this. Let's see if I can go ahead and convert. Sorry about that. Let's put that down a little bit so you guys can see. What this gives me says sine squared of x is equal to a 1 minus a cosine squared of x. All right, so therefore I have a 1 plus a 2 cosine of x plus a cosine squared of x equals a 1 minus a cosine squared of x. All right, this is getting in the way, so I'm going to move you down because I don't really think I was going to, yeah, I'll just do a quick little review for that student because they gave me a very vague, question. 1 plus 2 cosine of x plus cosine squared of x equals 1 minus cosine squared of x. All right, now let's get everything over to the same side set equal to 0 because I think we might be able to use some factoring here. So if I add a cosine squared of x, if I subtract a 1, then I'm going to be left with a 2 cosine of x plus a 2 cosine squared of x is equal to 0. Now I notice I have a cosine of x, so I can factor that out. So I get a cosine of x, factor that out, or I could actually, I'm sorry, I can factor out a 2 cosine of x. That's going to leave me with a 1 plus a cosine squared. No, sorry, cosine of x. So a 1 plus a cosine of x equals 0. Apply the zero product property. So therefore I can say 2 cosine of x equals 0. Divide by 2 on both sides. Divide by 2. Cosine of x is equal to 0. And then here I have a 1 plus a cosine of x equals 0. Subtract 1 on both sides, and I have a cosine of x is equal to a negative 1. All right, so now let's kind of go back up. I hate doing this, but I have to because I'm running out of space. So now let's go ahead and find our solutions, right? So we're going to do both of these solutions here. All right, so what are the values? Basically, think of like on the unit circle where cosine of x is going to equal to a 0. Well, that's going to be at a pi halves and a 3 pi halves. And then when is cosine of x equal to a negative 1, that's going to be at pi. All right, so that is the solutions between 0 and 2 pi. And I think that's what the student's question was. Yeah, between 0 and 2 pi. Now, though, remember, we squared it. So we have to be able to look at the... So we have to go and look for these extraneous solutions. So what I'm going to do is I'm going to plug these in. Now I'm going to do this mentally, all right, and just to make sure this works. So I'm going to apply it in 1/2, which is 1 over sine. If I go ahead and plug, so I'm going to do check. So I'm going to do check pi halves. So when I plug in pi halves, sine of pi halves is going to equal a 1. So that's a 1 over 1. Plus a cosine of pi halves is going to be a 0, which is equal to 1. And you can see that works out. So let's go ahead and check now 3 pi over 2. So 3 pi over 2 is going to be down there. So that's 1 over sine. That's going to be a 1 over a negative 1 plus a 0. Well, it doesn't really matter. You had 0 equals a 1. Well, 1 over negative 1, right, is negative 1. So that does not work. So that's extraneous. And then let's go ahead and check that's a 3, sorry. And then let's go and check pi. Well, sine of pi is going to be 0. So that's already, we can see that that's going to be extraneous. So therefore, that is not going to work as well. Okay, so the only solution that is going to work here, in this case, is going to be a pi halves. Voila. Now this student is saying go over factoring polynomials. So I actually have 2 questions that actually some student actually sent over to me for factoring polynomials. I'm just going to kind of go through though. I'm going to take a regular quadratic. And I think if you can understand factoring quadratics, then sometimes that can help you with your factoring of your polynomials. Okay, so that is what I'll kind of start with. Okay, so let's just kind of do a quick little factor in a trinomial, and then what I'm going to do is I'm going to show you 2 different ways we can write that as a polynomial using factoring techniques. So, for instance, let's have a x squared minus a 4x. Let's do a minus a 5. Okay, so just remember all quadratic trinomials can be written as a product of 2 binomials. So I can rewrite this as an x minus 5 times a x plus 1. Right, and the reason being is because we want to find what 2 numbers multiply to give us negative 5, add to give us a negative 4. Now, when our last number is negative, what we're doing is we're looking for the difference of our two factors, right? So the difference of our two factors of for 5 is 5 and 1, which is a 4. However, we want that difference to be a negative. That's why we want the -5, or that's why we want the 5 to be negative and the 1 to be positive. Now, let's go into look at some variations here. What about if I had a polynomial that looked like this? Let's do a plus a 3, plus a, and let's just, yeah, whatever, 4 x squared minus 5. Okay, so now here's a polynomial to the 4th power. Now, again, the same thing I want you to recognize here is though this is a trinomial. Now, it's not a quadratic trinomial. However, hopefully you kind of recognize that this looks very similar to all that, right? And one way we can do this is we can think about this as a quadratic, like rewrite it in terms of a quadratic, and then see if you can just raise the power of your factors. And in this case, you can, right? So in this case, actually, now we want our middle term to be positive, so that's actually going to be a positive 5. And this would be an x minus 1. And again, you just raise the power of your linear term. Because again, x squared times x squared is x to the 4th, right? And x squared times -1 and x squared times 5 is going to be a 5x plus negative x, which is a positive 4x squared, right? So therefore, you can see how that is going to work here. And let me just do one more example here. Sometimes we might get something like this, x cubed minus a 4x squared. Actually, let's do this. So that'd be a minus a 6 x squared, and this would be a plus of 5x. Okay, so then another way that sometimes we kind of mask a polynomial, but we can still use quadratic factoring, is by adding in an extra numbers that we can factor out. And so therefore, in this case, you can see we could just factor out an x, right? They all share an x. So factor out the x first. So we have an x squared minus a 6x plus a 5. Now what I want you to understand, though, is my last term is a positive, right? So now rather than finding the difference of our two factors, we're going to combine our two factors. So what two factors multiply to give us 5, but add to give us a -6? Well, that's going to be a -5 and a -1. So my factoring form is going to be an x minus 5 times an x minus 1. All right, so this one says angle and segment bisectors. So angle KYE is bisected by YL. So whenever I get a problem like this, the first thing I want to do is just graph it, just sketch the graph. Okay, so let's graph this. So we have an angle, K, Y. Hold on, I gotta respond to this. Okay, so I K, and then I have a Y, and then an E. That's a horrible E. But whenever a lot of times I like to kind of like visualize things, okay? So I always like to kind of draw. If it says I have an angle, let's draw it, KYE. And then that's bisected by YL. Now, the important thing is you got to understand this bisectors, okay? So bisectors is cutting something basically in half, all right? So if you have an angle bisector or a line bisector, that is cutting things in half. That means the two sides are now going to be equal. So therefore, these two angles are equal. Now it says KYE or KYE. Oh, KYE is equal to 150, but KYL is equal to a 4x minus 5. Now, if this is 4x minus 5, what does that tell you about this? Remember, they're equal to each other, right? If this is 4x minus 5, then that is a 4x minus 5, right? When you bisect something, those two sides are going to be equal to each other, or two angles, right? So what I have here is a 4x minus 5 plus a 4x minus 5 is equal to the whole angle, which is equal to a, what, 150. All right, so now let's go ahead and solve here. So 4x plus 4x is going to be an 8x. -5 plus -5 is going to be a -10 equals 150. Add 10, add 10. 8x equals 160. Divide by 8, divide by 8. X is going to equal 20. Now, again, what was the question? The question was just find the value of x, which, hey, we did. Done. All right, what about number 11? So that was number 10. What about number 11? So number 11 says IE bisects MR. IE bisects MR. Okay, so then these two, you can see they're going to be equal to each other. Solve for x. So if they're equal to each other, then I can just write this equation. 11x plus 3 is equal to 135. Subtract to 3, subtract to 3. 11x equals 138. Divide by 11, divide by 11. X is equal to, I'm not too sure, so I'm going to use my calculator. And, oh, that's a 135. Still, 11x plus 3 minus 3. Oh, that is all wrong. Okay. I'm not doing any of this work right. So 135, 11x plus 135. Okay. Minus 3, that's a 132. So 11x equals 832. So 132 divided by 11 is a 12. Voila. Okay, so 11 divided by 11, x is equal to a 12, and it just says solve for x. By the way, guys, I'm seeing some questions on there. If you'd like me to go over your question on the live stream, then just go to brianmclogan.com/Q&A. So this was the same student asking for factoring. So I need help finding extrema and end behaviors. So I'm assuming if you're finding extrema from the end behavior, you're not looking for the calculus, kind of version of this. So the extrema is just going to be your highest and your lowest point. That's basically going to be those points from on there, just to kind of simplify this approach. Okay, so actually, let's do it like this. Okay, so here's a polynomial. So these are all points of extrema. Okay, and basically you can kind of like detail it's a point of extrema if points to the left and to the right are either below it or points to the left and right are going to be above it. Now, there's variations of these types of extrema, right? So what I want you to do is I want you to look at these through the lens. Now, in each of these kind of boxes, all right, and I kind of want you to think of these boxes as like a TV screen. Okay. And each of these boxes, points to the left and to the right, are either below that point or above that point, right? So these two are the points to the left and right are below. So these are what we call maxes. Okay. Now this point is obviously points to the left and right are going to be above it. So therefore this is a minimum. All right. Now there's different types of maxes, right? Because when you zoom out to control the whole screen, right? When you look at it like this, what do you notice? Well, this is now the absolute highest maximum points. So that's what we call a absolute maximum. This is just that's still a max, but it's not the highest max. All right. So that's going to be a relative. Same thing over here. This is also a relative min because the graph continues going down, down, down. In terms of end behavior, what I would just focus on is like knowing this end behavior test. And if you don't already know this test, then I would just highly recommend knowing it because the main thing is, you gotta look at when you're trying to identify the end behavior of a polynomial, make sure you know the degree and the leading coefficient. Okay. So you want to know if the degree is even, if the degree is odd, if the leading coefficient is positive or the leading coefficient is negative. Okay. If it's even and positive, the end behavior is going to be up and up. If it's even and negative, the end behavior is going to be down and down or falls left, falls right. If it's positive and odd, it's going to fall left, rise right. And if it's odd and negative, then it's going to rise left and fall right. Okay, so if you can just remember that, remember the degree is going to be the highest power of your polynomial. The leading coefficient is the coefficient of that. So always make sure you have it in descending order with the highest degree first, going in descending order. And therefore you can identify that from on there. And hey, you're here. And does anyone have sub-final coming up? I have this one, so it'll be my first one. Well, awesome. Well, best of luck. All right, let's continue on. I can't believe I got that one. How do you do triangle statements in geometry? That's such a vague question. So I think the main thing, or I don't really know what else I can do. I mean, there's so many different ways that we can do it. We can do them in solve equations. We can do them in proofs. So the main thing I just want to, I guess, explain to you is, let's talk about some things that you cannot use. How do you do triangle statements in geometry? I guess the one thing I can state to you is, or at least a couple things to note. Okay, here's two things I want you to note about this because I'm not really sure what I can tell you to help you with this. But a couple things I can tell you is what does not prove congruency. Okay, that is going to be angle, 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 right? So that's one. Angle angling does not prove congruency, as well as the other thing that does not prove congruency is going to be a side-side angle. Now, what does do congruency is actually when you have a right angle, though, and it's side-side angle. That's what we call the HL theorem. So what does? Okay, so we can do is a side, 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 angle, side, angle, side, angle, We could do angle, angle side, right? And then 5 is we can do side, side angle. However, if it's HL, that means if it's 90 degrees. So these are all going to be your proved congruency. Now, how do you know which one of these you have? Okay, well, that's going to call up into the other part that I want you to know is like corresponding parts. Okay, so we can say this so corresponding parts. All right, so I don't know. Let's just say A, B, C, and let's do it like this. Because sometimes the orientation, guys, is like not the same. Okay, so 1, 2, 3, and then you can see, let's do this one right there. Okay, so this one's been flipped and flipped. Okay, and let's do this one X, Y, Z. All right, now how would we write this? Now again, notice like the tick marks, like A is congruent to Y, right? C is congruent to X, and B is congruent to Z. All right, so just make sure when you are like writing your congruency statements, just make sure you have corresponding parts, right? And so you want to make sure which angles or sides are going to be relating to each one. Okay, so we can say like A, C, B is congruent to triangle Y, X, Z. All right. So again, just make sure you know your corresponding parts as you're writing those congruency statements. But that's a little bit as of a vague answer because it was a vague question. Is reviewing past papers or actually doing practice problems more efficient for studying for a final? I think both of them really work. And I actually recommend that you do both of them from on there. So it really depends on how much time you have. If you have more time, then do more practice problems. If you don't have as much time, then just probably practice as much reviewing of much of the content as you can. But the main thing is like stuff is going to stick the more you do. Okay. So if you just need to cram, like you have 1 day, you have 3 days, review as much information as possible. It's not going to stick for very long, but hopefully if you review it enough, then it'll get you by for the test, right? If you have more time, like 30 days or 2 weeks, do some practice problems, really ingrain that stuff in for you. So it really kind of depends on your time, but I definitely include both. Chapter number 5, worksheet. Factor each completely. So the student did really good. And then, yeah, they just kind of got stuck here. So what you want to do now is just take the cube root of both sides. So therefore, A is going to equal 3. And B is equal to a cube root of, that's a 27. I think that's where they got confused. No, that's a 4. Sorry about that. Right? I'm not looking. No, that's 4. No, that's not 64. That's a 3 to the 4th power. Okay. So, all right. So 3 to the 3rd. Okay, so let's hold on. I got to simplify this. So that's 81. So I can rewrite that as a 27 times 3, right? So the cube root of 27 is going to be 3 times a cube root of 3. Interesting. They're at to do one. Oh, what? Wait a minute. I'm taking their stuff at stock. Okay. Hold on a second. No. Okay. No. I see what they did. All right. Here's where they made their mistake. I was just looking at their work taking stock. So once you factor it down, this is what you want to factor. This is what you want to cube, right? So it's not a cubed equals 81. We want to say a cubed is equal to a 27. Okay. And you could say, and I don't really want to do a cubed there. I want to rewrite this. What I would do is I would rewrite this as a 3 times an 8m cubed plus a 27. Okay. Therefore, now I can say a cubed is equal to an 8m cubed and b cubed is equal to a 27. All right. So now let's take the cube root of both sides. So a is equal to a 2m. Take the cube root of both sides. B is equal to a 3. All right. So again, remember they had that right. So that looks good. So now just plug it in. So you have a 2m plus 3 times a 2m squared. Sorry, I know I'm running out of space. So let's put it up top. Um, 2m squared minus a 2m times 3 plus a b squared. So that's going to be 3 squared. Okay, and sorry, make sure you're using parentheses here. That's a quantity 2m squared. All right, so now we have a 2m plus 3. 2m squared is going to be a 4m squared. This is going to be minus a 6m and then plus 9. And voila, there you go. State the equivalent expression for cotangent of 5 pi over 3 in terms of a related acute angle. So basically what we want to do is we want to find a coterminal angle. All right, so let's find 5 pi over 3. And basically all we simply want to do now is go ahead and either add and subtract 2 pi. So 5 pi over 3 is going to be right over there. Okay, so state equivalent in terms of a related acute angle. So we could do a couple different ways here. Hopefully you can see is we just want to find that angle. What is that angle, right? So that angle is just equal to a pi over 3, right? Because this is 5 pi over 3. All the way around the circle would be 6 pi over 3, right? Because 6 pi over 3 is equal to 2 pi. So remember that 6 pi over 3 is equal to 2 pi. We already went to 5 pi over 3, right? So how far are we away from the x-axis? We're pi over 3 away. Now, again, another way you could do this is you could subtract a 2 pi, which would be a 6 pi over 3. And that'd be negative pi over 3, which is exactly what we're at. But again, I think they were just looking for state equivalent expression. Oh, actually, I should, yeah. So that's going to be a negative pi over 3. So let's actually use the negative pi over 3 because that's going to take us to the fourth quadrant. We don't want to use the positive version. All right, this one student is asking me to graph this. So a couple things I think you need to know when you're graphing trig is know what the parent graph is. So y equals cosecant of x. Like, what does this graph look like? At least what is the parent graph? Okay, so everybody that is graphing needs to know this. Well, that's graphing trig. That's a really bad cosecant. Let's fix that. There you go. Okay, so it has an asymptote at pi, has another asymptote at 0, and this is going to be at pi halves, okay? So the asymptotes occur every x is equal to a pi n. That's the equation for the asymptotes. It has a period of 1, stuff like that. So basically, now we just need to know what these transformations are. So y equals a cosecant of x plus pi plus 1. So now this is saying the graph is being shifted pi to the left, right? And then being up 1. So you can just repeat this graph, obviously, as many times as you want to, but I'm just going to do like one of them. So basically, this whole graph is just being shifted. So this is going to be negative pi halves. And then it's being shifted up 1. So since this graph repeats every pi, there's actually, that change is actually not really doing anything to that, right? Because this graph is going to repeat again. It's going to happen again over here. So the shifting of a pi to the left is really a meaningless kind of transformation, but it's still something important to note. And then the plus 1 is obviously shifting the graph up 1. Okay, so I want to make sure you're aware of that. But our asymptote equation is going to remain the same. All right, so here's another example of another polynomial to factor. So actually I did that one polynomial factored. That was the difference of 2 cubes. And here's another polynomial to factor, which is going to be by grouping, okay? So in this term, we have 4 terms. So when you have 4 terms, look to group, all right? And what I mean by grouping is group the first 2 terms and group the last 2 terms. You don't want to turn it into a multiplication problem. Just group the first 2 terms and the last 2 terms. Now what you're going to do is say, all right, what do these have in common? Well, notice that I can divide a 3 into both of them as well as an x squared. So I'm going to factor out a 3x. By factoring out a 3x, I'm going to be left with a 3x squared, I'm sorry. That's going to give me with a 7x, and then this would be minus a 6. Yes. And then notice here I can't really factor anything out, right? But I got to have something. So I'm going to factor out a positive 1. And that's going to leave me with a 7x minus a 6. Okay, now notice these are exactly the same. All right, now remember, if I had like a 3x, I don't know, plus a 7x, couldn't you factor out the x's? Couldn't you do this as an x times a 3 plus 7? Couldn't you do that? You could, right? And sometimes when we're first learning about like factoring or combining, that's exactly what we do, right? Because that's how you add monomials, right? You're adding the coefficients of your x. So in this case, since these are both the same, I can factor this out. 7x minus 6. And what that's going to leave me with is a 3x squared plus 1. Okay? So now I have that, and now it's in my factored form. So there you go, ladies and gentlemen. Oh, forgot to turn that off. Sorry about that. I think that's all for the questions are for today. So um, just remember, guys, if you have more questions for your exam, hopefully, guys, I wish you best of luck, but you guys can go to brianmclogan.com/Q&A. Also, if you are in pre-calculus and would like to go and take a look at my reviews that I have for the semester exam as well as for the final exam, then you can go and check out that link in the description. Well, otherwise, I will see you guys at sometime tomorrow. I don't know yet, so click the notifications and or the bell to get notified when I do go live, and I'm happy to answer your questions. All right, guys, I wish you the best of luck on your exams and hope you have a great week. Cheers.